Hi everyone, this is the second lesson for Unit 5-4. We're talking about dividing polynomials, and today we're going to talk about synthetic division. So our goal is to understand and apply the synthetic division algorithm, just a series of steps to go through. And then our essential question is, how do we interpret the results of synthetic division? And you'll see as we work through these, the process itself is actually pretty quick. But there is some thought you have to put into getting it set up properly, and then also how you interpret the results. So these are some of the same examples we looked at in yesterday's lesson. We're just going to do these again today using synthetic division. And you see that again, the process goes fairly quickly, but you do have to set it up correctly in order for it to work. So we're going to be dividing the binomial x minus 5 into this quadratic trinomial, right? This x squared plus 3x minus 40. Now, the thing that we're going to do here to set this up is we're going to look at the coefficients of all of these, right? So if I look at this, the coefficient of this is 1, the coefficient of this is 1. So we're going to be looking at those coefficients. We also, like in long division, want to make sure that we're not missing any terms. So here I have an x squared, here I have an x to the first, and here I have a constant. So I have all my terms there, and I have an x to the first and a constant here, so I'm not missing any terms. So I've got all the terms accounted for, my largest to smallest, and they're all there. So to set this up, we're just going to first of all just start by writing the coefficients of the numerator. Okay, so I'm just going to write these numbers out: 1, 3, and negative 40. Okay, and then we're going to write another number out here, and we kind of make this little box like this, and we're going to put another number in there, and the number that we put in there is the number that would make this polynomial on the bottom equal to 0. Okay, so if I put in 5 for x, this would make this 5 minus 5, that would be 0. So I want to put in the value for x that's going to make that 0. So in this case, I'm going to put in 5. And then I'm going to leave a little space and draw a line underneath here. Okay, so this is how you set it up. This number inside here is usually the opposite of whatever this number is. Okay, so I've got a negative 5 here. I'm going to put a positive 5 in there. So, so here's how the process works. We're going to take this first number and we're just going to bring it straight down. Okay, so that 1's just going to come straight down. And then we're going to take this number here and we're going to multiply it by this, right? So we're going to multiply 5 times 1 and we're going to put the result right up here. So 5 times 1 is 5. Put that there. And then I just simply add these two numbers together. 3 plus 5 is 8. And then I just repeat that process. 5 times 8 is 40. And I'll just add these together and I get 0. Okay, so I'm done with the synthetic division process. Now we have to look at how to interpret those results. Okay. Now I started with an x squared term here, right? And I divided an x into it. So my result is going to be a term that has an x in it, right? It's not going to be an x squared, it's going to be an x. And so the way that I look at this is these are the coefficients of my answer, right? And then this last number down here is the remainder. So the way that I would write this out, this is 1 and it represents the x term. So this is 1x, and then this is 8. That's the linear or the constant term. So it's 8, x plus 8, and I have a remainder of 0. So my remainder here is 0. So how would I write this out? Well, I would say this x squared plus 3x minus 40 divided by, whoops, lost my division symbol there, divided by x minus 5 is equal to x plus 8. And again, my system's kind of slow today. X plus 8, and the remainder there is just simply 0. Okay. So again, what that means is that if I multiplied x minus 5 times x plus 8, then I would get this, this polynomial. All right, so the synthetic division. Let's look at another example here. So here we have this problem, and so yesterday we had to rewrite this in standard form and make sure that we had all the numbers. And it's still nice to do that, but we don't need to be as careful about that. We just need to make sure that we have all of the terms here. So I start with a cubic, so I've got a cubic, I've got a quadratic, I've got a linear, and I've got a constant. So I've got all my terms there, right, from the cubic all the way down to the constant. And then on the bottom I have 2 minus a. And again, I'm trying to find the number that would make this 0. Okay, so I'm going to set this up. I'll just write out the coefficients here. So this is 1, 2, 4, and negative 9. And then in the box over here, I'm going to put the number that makes this 0. So I have 2 minus a. My a here has to be 2. Okay, if I plug 2 into this, it would make that denominator 0. So this is what we're looking for now. So we're just going to run through that process. We're going to bring this first number straight down, multiply 2 times 1. That goes right here. And I'll add those together. 2 plus 2 is 4. And then I repeat that process. 2 times 4 is 8. I'll add those together. I get 12. And to repeat that process, 2 times 12 is 24. And so if I add those together, I get 15. Okay, so there's the synthetic division. Now we have to interpret these results. Remember that this last term out here, this last number out here, represents a remainder. Okay? And I started with an a cubed, so this is going to represent the a squared term. So this is going to be a squared plus 4a plus 12 with a remainder of 15. Now, sometimes the questions will ask you what the remainder is. In this case, we would say 15. Sometimes it's going to ask you to write that out. And remember that that 15, that remainder, represents a fraction. So if we were to write out the actual answer to this division, it would be a squared plus 4a plus 12 plus 15 over 2 minus a. So here's one way of writing the result. So I have the polynomial and the remainder, and then here's another way of writing that result where we write the remainder as another term in our polynomial. And we'll look at our last example here. So here's an example where again we're just dividing a polynomial. But if I look at my numerator, I've got an x to the 4th. I'm missing my x cubed term. I have an x squared, but I'm missing an x term. So when I write out my coefficients, I just need to make sure I take that into account. So when I write out my coefficients, I'm going to write 1. For that x cubed term, I'm just going to put 0. I have 0 x cubes, negative 4. And then my x term, I have 0 x's. And then I have 4 for my constant term. And then the value I'm going to put on the outside is whatever makes this 0. In this case, it's going to be 4. And I write my line out like this. Bring my 1 down. Go through that process. I get 4, 4, 16, 12, 48, 48, and it looks like 192, and so I get a remainder of 196. Okay. So So this is my polynomial. Again, I started with an x to the fourth term, so this represents x cubed. X cubed. And you see, it's important to put in those placeholders because I do end up with an x squared term in there and an x cubed term. That's 4x squared plus 12x plus 48 with a remainder of 196. Okay, and again, I could write that remainder as a fraction. I could say plus 196 over x minus 4. And that would be the other way to write that. All right. There's one other thing that you can do with synthetic division, which is actually a pretty neat thing, in that you can use the synthetic division process to actually evaluate a function. You can evaluate a function at a given value. So if I said, for example, let's say that f of x was, and I'll just make something up here, let's go 3x cubed minus x squared plus 4. Okay? And I wanted to know what f of 3 was. So I wanted to plug 3 into this function and evaluate it. Okay? Now, the cool thing is that you can use the synthetic division process to do that. And so what we're going to do is we're going to set this up just like synthetic division. So I'll go ahead and write out my coefficients. I've got an x cubed, a 3x cubed, I've got negative x squared. I have 0 x's, so I'm going to make sure I put that placeholder in there, and 4. Okay. And then this time on the outside, since I'm not dividing by a polynomial, I'm simply evaluating at 3, I'm just going to put that number in there. So I'm going to put 3 into there. So that means if I plug 3 into this function, this should tell me what my result is. And so again, I'll just walk through that process, bring the 3 straight down. 3 times 3 is 9. 9 plus negative 1 is 8. 8 times 3 is 24. My handwriting's getting bad here. Add those together, I get 24. 24 times 3 is 72. And then when I add that together, I get 76. So what this means is that when I plug in 3 into this function, the remainder here is my answer. This is the value that I get when I plug in 3 into this function. I get 76. So it's a nice quick way of evaluating functions without having to, type out the whole thing into a calculator and build a table of values, or build a lookup table or anything like that. It's just a quick and easy way to do that. This is called the remainder theorem, so you'll hear it referred to as the remainder theorem, and it just simply says if you use the synthetic division process, it's the same as evaluating that function at the input value, right? So in this case, the remainder theorem says that if I evaluate f of 3, then I would get 76. Right? 76 is the remainder of my synthetic division process, so 76 is what f of 3 would equal. Right? So it's a nice handy trick. Okay, I'm going to go ahead and end the lesson there and take a look at the rest of the 5-4 assignment, and let me know if you have any questions.